Alright, in 7.3 we're going to graph rational functions. We're going to take what we learned in 7.1, 7.2 and try to figure out how to graph these things. So we still have to find the vertical asymptote, horizontal asymptote, and the domains, and then we'll plot some points and graph them. Now this first rational function, if you remember, when you're finding the domain, what you look at is the denominator. So you're going to look at the denominator. Of your function, and you're going to ask yourself, what makes that denominator equal 0? And that's the value that cannot be in the domain. So looking at this denominator, 1 would make that denominator equal 0. Since the denominator can't be 0, we know then that x can't be equal to 1. And that's also where your vertical asymptote will be, so that's the line x equals 1. So we're going to go over and put that on our graph at x equals 1. And then we're going to go back and figure out what our horizontal asymptote is. For the horizontal asymptote, remember you're looking at the degree of the numerator and the denominator, which is the highest power of x and there's 3 possible choices for your horizontal asymptote. If the numerator degree is less than the denominator degree, then the horizontal asymptote will be y equals 0. If the numerator degree is equal to the denominator degree, the horizontal asymptote is going to be y equals a over b, and a and b are the coefficients that are in front of the highest power of x in those polynomials. And if the numerator degree is greater than the denominator degree, then there is no horizontal asymptote. And those are your 3 possible answers for that. So looking up at this equation, if there is no power of x there, it's understood that that's 1. So the degree of the numerator is 1, and the degree of the denominator is also 1. Since the numerator degree is equal to the denominator degree, then we look at these numbers in front of the x's, which are the coefficients in front of the highest powers of x. In this case, there are no numbers there, so they must both be 1. So my horizontal asymptote is at y equals 1 over 1, which is 1. So we're going to draw that in. At y equals 1. And then we have to plot some points. Now it's going to be, we're going to pick our x's and we're going to pick them to the left of the vertical asymptote and to the right of the vertical asymptote, remembering that it can't be that one where the vertical asymptote is sitting. So I'm going to remind you, I'll write up here, you pick these numbers. You choose the x's. So we're going to pick 0, -1, and -2. And then on the right side of the vertical asymptote, we'll pick x equals 2, 3, and 4. Then we're going to put these numbers in our original equation, which is x plus 1, our original function, over x plus 2 over x minus 1. So we're just going to plug those x's in. We'll have 0 plus 2 over 0 minus 1, which will be 2 over -1. So that's negative 2. Then we'll put in the negative 1. Which will be 1 over negative 2, or negative 0.5. And then we'll have negative 2 over negative 2, which will be 0 over negative 3, or 0. Going up here on the other side, the other graph, we'll have 2 plus 2 over 2 minus 1, or 4 over 1. Then we'll have 3 plus 2 over 3 minus 1, which is 5 over 2, or 2.5. And then we have 4 plus 2 over 4 minus 1, which is 6 over 3, or 2. So now we're going to plot these points on our graph. So at 0, negative 2, negative 1.5, negative 2, 0. Then we have that curve. We can draw it in and know that on either end of that, it's going to have this asymptotic behavior, getting close to those asymptotes and never crossing them. And on the other side here, we'll have 2, 4. Three, 2.5, and 4, 2. And then we can draw in this function on this other side of the vertical asymptote. And so that would be our graph of this first example. Now let's look at our second example. Again, at the domain, we figure out what makes the denominator 0, which will be negative 2. Okay, so that means x cannot be negative 2. X is not equal to negative 2, and our vertical asymptote is at x equals negative 2, so we can draw that in there. Okay. Then for our horizontal asymptote, we look at the degree. If there's no x there, the degree is 0, so the degree of our numerator is 0, and the degree of the denominator is 1. That's the highest power of x. So my numerator degree is less than the denominator degree, which if you look at the notes up there in the left margin, that means that our horizontal asymptote is at y equals 0, which is the x-axis. So we can put that on there. And now we need to pick points to the left and to the right of our vertical asymptote, here and here. Okay, pick our x's. So left of negative 2, so we'll start with negative 3, negative 4, and negative 5. And then we'll go to the right of negative 2, which would be negative 1, 0, and 1. And we have to put it in our original function, which is 3 over x plus 2, to figure out our y values. So 3 over negative 3 plus 2 will be 3 over negative 1, or negative 3. Okay. Then we'll have 3 over negative 4 plus 2, which will be 3 over negative 2, which is negative 1.5. And then 3 over negative 5 plus 2, which is 3 over negative 3, which is then negative 1. And on the other graph, we'll have 3 over negative 1 plus 2, which is 3 over 1. Three over 0 plus 2, or 3 halves, which is 1.5. And then the last one for this particular problem is 3 over 1 plus 2, which would be 3 over 3. Alright, so let's graph those points and draw in our graph. So we have negative 3, negative 3, negative 4, 1.5, and negative 5, 1. Drawing our curve. And then we have negative 1, 3, 0, 1.5, and 1, 1. And drawing our curve. Okay, so that's example number 2. There's one more example in this set of notes. Same process. What makes the denominator 0 would be a 1. So though x can't be 1, and the vertical asymptote is at x equals 1. So we put that in. Okay. Then for our horizontal asymptote, looking at the degree of the numerator equals 2. The degree of the denominator equals 1. So the numerator degree is greater than the denominator degree, which means that there is no horizontal asymptote. We pick points just like we did before, to the left and to the right of the vertical asymptote. So our points will be -0, -1, and -2, and then 2, 3, and 4. And we're putting them in x squared over x minus 1. Okay. So we'll have 0 squared over 0 minus 1, -1 squared over -1 minus 1, and -2 squared over -2 minus 1, which would be 0 over -1, or 0, 1 over -2, so -0.5, and 4 over -3, which is -1.3. Okay. Then on the other graph, we'll have 2 squared over 2 minus 1, which is 4 over 1. We'll have 3 squared over 3 minus 1, which is 9 halves. So as a decimal, that's about 4.5. And then we have 4 squared over 4 minus 1, which is 16 thirds, which is 5.3. I make these decimals for graphing just because it's easier to locate on a graph. Okay, so at 0, 0 we have a point right there at the origin. Then you have negative 1.5 and negative 2, negative 1.5. And so this graph looks a little different. The asymptotic behavior is going to be a sharp curve here from this top point, and then this curves and goes kind of out like that. And again, this is a sketch. This is not an exact graph. Then we look at our other graph, and we have 2, 4, 3, 4.5, and 4, 5.3. Again, we have this line that curves sharply back and up towards the asymptote. Oops, that didn't look too good. Let me try that again. Comes there, and then it hits that point, and it's going to curve sharply that way. And that's how these graphs with no asymptote look, generally speaking, are the ones you'll be dealing with anyway.